And then I will finish with a sketch, perhaps a little more detailed sketch of what the Friday program is going to require. You'll remember on Friday I started some of that with the rule array and converting numbers to binary, and I want to continue that discussion. Before I do so, any questions? All right. So random numbers in computer science are a really big and important topic. Random number generators are used in encryption algorithms for computer security. They're also used for simulations. If you want to simulate traffic patterns, or you want to simulate just all kinds of things. You want to simulate what happens at a red light at a particular busy intersection. So you have some frequency of how often cars come up to this red light, and you kind of just push this random number. You have this random number generator that generates cars that come into this traffic light, and then they wait there for a while, and then they're released. And a traffic engineer might run a simulation like this, might run thousands and thousands of simulations to see if at any point during the simulations there are backups or something that are really dangerous or annoying or whatever, and then they'll maybe tweak the timing on the lights and run the simulation again to see if that's a better timing. This is really, you wouldn't do it with a single light, but what you might do it with is like a whole city grid of traffic lights, and then you would run this simulation where you have these cars moving through this grid, and you see if there are any choke points that need to be resolved. So simulation is a really important application of random numbers. The problem with random numbers and computation is computers want to do the same thing all the time. Right? How do you get random numbers out of something that is precisely designed to follow an explicit set of instructions from beginning to end? And the answer is you don't. You don't get random numbers out of a computer program. You can't do it. So what's the solution? How do we get randomness in our computers? What we call it instead is something called pseudo-randomness. We have these special functions called random number generators that generate integers over a particular range. So for example, a really simple random number generator might generate numbers between 0 and 99. And the likelihood, every time you call this function, every time you ask for a random number, the likelihood of getting 0 is the same as the likelihood of getting 17, which is the same as the likelihood of getting 99. So we have a uniformly likely set of outcomes in our random number generator. That's called a uniform random number generator. It follows what's called a uniform distribution. That's in fact what we have available to us in C++, is this function that spits out a number somewhere between 0 and a constant called rand max, which is somewhere around 4 billion. Let me show you that function. To use the rand function, I have to include C standard lib at the top. And let me just show you how it works. Okay, there's a random number between 0 and 4 billion. Let me run it again. And run it again. And I'll run it again.
What are the odds?
Exactly, right? So, as I mentioned, there isn't a way of getting a computer to generate random numbers. So we have to somehow introduce randomness. So what we can do is we can set the seed for the random number generator. So this rand function, let me call it twice. So if I call it twice, I get this second different number. The first one's the same. And if I call it twice, so there's nothing, let me call it 3 times. Okay, so it's always starting and it's always running through the same sequence of numbers. And the only interesting thing about this sequence of numbers is that if I run it for a really, really, really long time, we will find that those numbers are uniformly distributed between the numbers 0 and rand max. That's the only thing that's really interesting about this. Other than that, it's completely deterministic. It will generate the same sequence of numbers every time. So what you can do is randomize where you start in that sequence. We haven't quite solved the problem yet, Chase. But what we can do is change the starting position. Using something called srand. So let me try that, srand. And I'll just start it at 5. And we'll run this guy. So if I set srand to 5, you see I get 3 completely different numbers from the pattern that we were getting before. But if I run it again, so I haven't really solved the problem yet. So the effect of starting this thing at 5 means that I've jumped into this completely deterministic sequence. I've jumped in somewhere in the middle, and now I'm just moving forward in that particular sequence. I can change the seed, say to 10, and get a different sequence. But if I run it again, I keep getting the same sequence because now I'm starting at 10. And I'm using small numbers, but you could use a really large number as the random seed, and you would get that you would just dive into the sequence at a different location. All right, how do we get a program that at least changes where the sequence starts over and over again? Ideas?
Could you make that number a variable and then have them input it, and then it would like go?
Sure, absolutely. So we could do something like cout, enter random seed, and then I could do cin seed, and we'll declare seed up here as an int. In fact, it can technically be an unsigned int. And then we can put seed in here. And let's see how that works. So I'll run that guy. It asks for a seed. I'll put in 10. And you'll see that I get that same sequence. But if I put in 11, I get a different sequence. If I put in 12, I get yet another sequence. Go ahead.
Could you do a while loop and just have a counter? So every time you press enter, it would go to the next seed number?
Okay, so that would be another way of doing it. But what about the first time, right? I'm going to give this program out to somebody, and they're going to run it the first time, and it's still deterministic. It's still, in some sense, going to be running through the same sequence of seeds. Go ahead, Dylan.
Can you randomize seed itself?
Can I
randomize seed itself? So like negative variable to randomize that, so that you can randomize where you start.
I can't randomize it, but I can put something in there that changes depending on when I run the program. And that leads me to the next include here. What I can do is seed the random number generator with the time that I ran the program. And if I run the program, as long as I run the program more than 1 second apart, I'm going to get a different seed. But if I run it twice really fast, I'll get the same seed, because the time thing is going to run on seconds. So let me show you how to do that. So here is an example of time seeding. We've already got a seed there. we don't need to use that. I'm going to comment this guy out just to remind you guys how this was working. And instead, I'm just going to call the system time. Time is weird. It needs an argument, so I just give it 0 as an argument, but that has no bearing on this discussion whatsoever. What this will do is it'll go out and get the number of seconds from the system clock, and it will use that to seed the random number generator. And now I'm getting different sequences of numbers based on when I run it. If I do it really fast, you can see I get the same sequence because I happen to do it in the same second. And time is returning the number of seconds. Yes?
So is it only using the seconds? So can you only have 60 different...
So it's using the number of seconds that have elapsed since January 1st, 1970. So that's going to continue to increase up until the year 2037. Anybody have that question? Okay. So that's related to that question. What's important about the year 2037? That's when we run out of seconds from, that's when the number of seconds since January 1st, 1970 exceeds the size of an unsigned integer, which is not a good thing.
Can you reset it? Can you reset that clock somehow?
No, not real. I mean, you could change the computer's clock, and then that would affect the time function. So I could take the computer's clock and set it back 5 minutes, and I could have all this discussion again, and I could have the same sequence come out. But that number just continues to increment all the way up until the year 2037, in which case it'll wrap around and go back to 0. So you get a different number every second that you run it between now and 2037. Yes?
The clock is more precise than just the nearest second, right? It can be.
This guy is seconds. There are several other member functions of the ctime library. One will get you milliseconds, I think, which makes it even harder to run the program twice at the same moment. But that would not have let me illustrate my point of running it twice really fast in the same second. So does everybody see how this works? The random number generator really is just generating a predetermined sequence of numbers. What's special about that sequence of numbers is that they are uniformly distributed, and I can pick where I want to start in the sequence using the seed. So there's not really true randomness. One of the best attempts I've seen at true randomness, let's see if it's still there. I don't know if it's still there. Lava Rand. It's promising. Yeah, it's not there anymore, but there was a tech company called Silicon Graphics that essentially had a camera pointed at a collection of lava lamps. And if you wanted a random seed, what you would do is grab an image of the lava lamps, and then you would sort of digitize that image and turn it into an integer and use that as your random seed. And people have actually determined that lava lamps are totally random. So that's a good random seed to use. But once you pick the random seed and then you dive into the rand sequence, now you're back into a completely deterministic algorithm. So the only way to truly and of course, so then you say, well, why don't I just pull a picture of the lava lamp every time I want a random number? The problem is, while the lava lamp is unpredictable in a sense, it's not going to generate uniformly distributed numbers. And so you want to take that lava lamp picture as the seed, dump it into a random number generator, and then you'll get uniformly. Why do we want uniformly generated random numbers? Because if I have a uniformly distributed set of random numbers, then I can take that and turn it into any kind of distribution that I want. Sometimes you might want normally distributed numbers around a particular mean. Well, I can take my uniformly distributed numbers and push them through this other function and get a normal distribution or something like that. So we always like to have uniform random number generators. Any questions? Okay, I introduced this because we'll be using RAND in the future, and also I wanted to use it just as an example to play around with arrays a little bit, a somewhat interesting example of playing around with arrays. So let's get out of here, and let's just look at generating a random array. So I'm going to include C standard lib for the rand function, and I'm going to include C time for the time function. And I'm going to declare an array. Let's make it an array of size 80. And what I'd like to do is fill this array up with random numbers, say between 0 and 10, or say between 0 and 9. Let's do that. All right, so let's get another int I. And what's a quick way of visiting every element in this array? AI, and where do I put the AI? Inside a loop, right? So if I put this AI inside some kind of loop that runs 80 times, then that's a quick way of getting at all of these elements. As opposed to A0 is rand, A1 is rand, A2 is rand, and so forth. I can automate that process by shoving it into a loop. So I can use a for loop, I equals 0, I less than. If I want to go across all of the elements, what's the highest that I should be? 79, right? Not 80. 79. And I can assign a random number to it. So this loop is going to visit every element in the array. It's going to visit every element in the array A and put a random number in there. Now, I'd like to put a random number in there between 0 and 9. Anybody know a quick way of doing that? There's an easier way, and I don't want to change rand max because that's a system constant that I want to rely on as being around 4 billion. But you're kind of on the right track. How do I make that happen? Remainder by 10. Good. Okay, so rand is going to generate a number between 0 and rand max. When I do %10, what do I get out of that? I can only get 0 through 9 out of that. No matter what rand was, I can only get 0 through 9 out of that. Now, suppose I'd like to see the contents of the array after I filled it with these random digits. How would I do that? Right now, if I run this program, what's going to happen? But I'm never going to be able to see what they were, right?
Do you need a CF statement inside the for loop?
I could put it right here, sure. I'd like to separate the generating and the printing. So if I want to separate that in the program, how would I do that? Meh. How about another for loop? Okay, so I'm going to make a for loop that fills the array, and then a for loop that shows the array. I know, I'm being slightly ambiguous. So for I equals 0, I less than 80, I plus plus, cout AI. And then just for cleanliness, we'll do a cout end line. Okay, so there are 80 random digits. And if I run it again, what will I get? I'll get the same thing. So if I want to get more random numbers, I'll do time seeding. So let's do srand time 0. And run it again. So now I'm getting truly random, not truly random, but more random seeming numbers than I was getting before. All right, what if I want, instead of numbers between 0 and 9, I'd like just numbers between 0 and 1?
Do you need to change it to double?
Change the remainder.
Yeah.
Change the remainder, yeah. How? Change it to 2?
Oh yeah, it's 2.
If I change it to 2, then it's going to be 0 when the number's even, and odd when the number is, and 1 when the number's odd, right? So let's do that. There you go. And what if instead of printing out 0 or 1, I want to print out either a space or a pound sign? Something like that. You can see where I'm heading with this, right? For those of you that can't see, maybe you missed the demo here. Let me run the demo again. Okay. See that bottom line right there? That looks a lot like what I was doing in the other thing. If a cell is alive, print out a pound sign. If it's dead, print out a space. Now that's not with random numbers though. That's with the rule, applying the rule over and over and over again. But in terms of rendering each line, line by line, it's really just something like what I just described. Now, it's considered bad form to put things like a pound sign or a space character in your code. Instead, what you should do is use something called a named constant. And there are two ways of introducing named constants. And I'd like to share with you both of those ways. These are both characters. And why is it bad form? Let's do a const character live equals that, and const character dead equals that. And then down here, let's do live dead. Why is that a preferable thing to do? 2 reasons that I can think of. There may be more. One reason? Yeah, right. It's not really clear when I'm printing out a pound sign, what do I mean by that? But when I see out live, that's suggestive to me as I read this thing that I'm printing out a live cell. Okay, that's one. Good. Can anybody think of another one? This is perhaps a little more esoteric. Not really, but...
So then if someone else wants to use your program, they just need to change what live equals.
Yeah, so suppose somebody wants to use an @ sign for a live cell instead of a pound sign. Just go up there and change that one line, and then if you, the programmer, have been consistent in your use of that constant everywhere, then they only have to change it in one place and recompile, and everything is lovely. Yeah.
Is it bad form to use lowercase letters with your transcript?
Yeah, I tend to use uppercase letters. I'll tell you where I use uppercase letters. So here I'm kind of ambivalent about whether you use upper or lowercase. But let me show you the second way of defining constants. And the second way I tend to always use uppercase. So these guys are these are constant data types, or constant data. And I'm going to comment these guys out and do it a slightly different way. Here's the way I tend to prefer. Oops. These are called compiler directives, or pre-compiler directives, if you want. There are 2 things to note here. This is using an entirely different process to introduce the constants. And if I use these constants, let me go down here and change these to uppercase. Oops. Whenever I do defines at the top, I usually use uppercase, and that's just sort of the industry standard. What's going on here is similar to these include statements. Does anybody remember how the include statements work during the compile process?
The compile goes through and replaces those with a whole set of nodes, I guess.
Exactly. So if I locate IOStream out on the system. Okay, it looks like it's right there. And if I look inside that file, whoops. The preprocessor is literally going to go out onto the system. It's going to find this file and stick it at the top of your program before it feeds it to the actual compiler. That's what include does. And there's a whole bunch of gobbledygook in here, which is not important for you to know. Okay. The define statement does a kind of a similar thing. So it says the preprocessor gets to here and says, okay, anytime I see capital LIVE, I'm going to replace it with apostrophe pound apostrophe. So it goes sailing through your code, and it encounters this string right here, LIVE. And it literally does sort of a search and replace. It replaces that LIVE with apostrophe pound apostrophe. A common error when you're doing this is to put an equal sign here. That's not correct. It's just a space, and it's really just saying whenever you encounter this string live, replace it with this other string apostrophe pound apostrophe. The reason I like this a little bit better is because it moves those constants much closer to the top of the program, and these kinds of things that you want to let others change, the closer to the top of the program that you can get them, the better off you are. So these constant character things down here, to me, they're constants that you as a programmer might be interested in changing. Whereas the constants up top are constants that you might be willing to let other people using your program change.
So when we did the bisection method, could we have put, can you use like a string for our functions up top? Like f equals x squared minus 1 or whatever?
You can, but I think that's not really the intention. But you can actually do that. Yep. So you could have just let f be, x squared minus 1 or something like that. And yeah. All right. Questions about this example? Yes, Carter.
If you have live in like a C out in the parentheses, would it change it to that stuff at the top, the pound?
If I had it where?
Like in front, like you had C out, the things in parentheses.
Like that?
Or no. Quotation thing.
Ah. Probably get a compiler error. No, I think what you would get is, yeah, you'll get a, I think what you'll get is inside, it'll print out the string apostrophe pound apostrophe.
Okay. So like even if you had it in comments, it would change it. Like it wouldn't do anything.
It's probably smart enough to not do anything in comments, because the preprocessor is probably smart enough to know what's in a comment and what's not, and won't bother. But it doesn't really matter because, as you mentioned, you're never going to see that, right? This is something that the preprocessor goes through, makes these changes, immediately sends it off to the compiler, and you don't get to have a peek at it in between. Ami, did you have a comment?
Yeah. What kind of type is the defined?
It's no type. It's a lexicographical substitution. So it's not a data type. It's literally just what you do, like when you're in Microsoft Word and you do search and replace. Okay. All right, let's talk a little bit more about what you can and can't do with arrays. So let's suppose I have an integer, a two-dimensional integer array. Let's say A10, A8. So this array has 10 rows and 8 columns. If I do something like this for I equals 0, I less than 10, I plus plus, for j equals 0, j less than 8, j plus plus, C out Aij, and let's put a space in there maybe. Well, let's just leave it like that for now. What am I going to see on the screen if I do this? Well, yeah, I'm going to get a compiler error first. Thank you.
Will it just give me the diagonal?
It's actually going to give me it's going to visit every element. So that's not the issue, right? Because I start I equals 0, and then for 0, I get 0, 1 through up to 7. For 1, I get 0 to 7. For 2, I get 0 to 7. So it's going to go down and do every row. That's no problem. Yes. So if I run this thing, I get lots of junk. What's the deal? Where's the junk coming from? It's whatever was sitting in that block of memory before. This is an uninitialized array. if you want to initialize an array, say to all zeros or something like that, sadly you can't just go A equals 0. And I'm not even sure that that'll give me a compiler error. Oh, it will. Okay, good. Some flavors it won't give a compiler error. So that's not how you do it. So if I would like to have a 0 in every entry of this matrix, how do I do that? Well, I can just put a 0 in, but I literally have to visit every element. That's the point that I'm trying to make. So I have to go through a whole set of loops and set every one of them to 0. There's nothing easy about arrays. There's nothing built in that makes things easy, like I can initialize everything to 0 or whatever. I literally have to go and visit every element. So here's how you would initialize every element. And we know that initialization is important in some cases. If we want to rely on particular values being in the array, we have to do this. Oh, now I have my cout. Let's go run this again here. And let's do cout. So now I see all zeros. How many zeros are there? 80. There are 80 zeros. What if I'd like to see this in a more matrix-like or a more rectangular kind of situation? How would I tweak my printing loops? Jordan?
You do an end line after the 4J.
Between these two guys?
Yeah.
Yep. And now you're seeing the rows of the array. Okay, what if I have another array up here, B, and it's the same size, and I would like the contents of A to be in the contents of B. I would like to copy the contents of A to B. Sadly, we can't do this. So I can't do that. How do I do it? Go ahead, Sarah. Yes, so and I literally have to go through and visit every element and do that. So I need a whole other for loop, and then down in here I have to go through and take the contents of Aij, put them into Bij, and then I can print them out or what have you. So this is initialization. This is printing the array, and this is copying the array. Questions about that? What if I want to initialize, what if I want the whole A array to be 0 except the third element in the fourth row? How would you do that?
Do like if I equals 3 and j equals 4 there.
So the easiest way to do it, what if I want to just set A, let me be, yeah, I'll just give it away. What did I say, the fourth element?
The third element in the fourth row.
third element in the fourth row. So that's A3. Fourth row is 3. I forgot what I said. Third element? 2. There we go. So remember that the first entry is the row number, and the second entry is the column number. And remember also that the first row is 0, is row 0. The second row is row 1, etc. The first column is column 0. This first column is column second. Second column is indexed j equals 1, and so forth. So the easiest way to do this, and you'll see this all the time, don't put an if statement in here and try to catch when I is equal to 3 and j is equal to 2. Just let it be 0. Just write the whole thing to 0, and then when you're done, do that. And I'm going to move this guy up here so that we can actually see it. So, right, this array up here is responsible for setting everything to 0. And then I didn't want everything to 0. I wanted a couple of them to be 1, or just one guy to be 1. And so I just go through and do that. Why is it better to do this than to put an if statement in here?
It's a lot easier.
It's easier, yeah, definitely. Think about efficiency and what the computer has to do. If I put an if statement in that loop, it's got to check that if statement 80 times, which is computationally intense. Instead, we'll just do one unnecessary assignment instead of 80 checks, if checks. And then we'll do this guy down here. Let's see what that guy looks like. And there it is. Fourth row, third column, there's a 1. What if I'd like the whole diagonal to be 1? Or as many of the diagonals as I can, because this is not a square matrix. So I want 0, 0, 1, 1, 2, 2, etc. So I need a loop, right? And how far can I go along the diagonal? 0, 0, 1, 1, 2, 2. I can only go up to 7, right?
You also do it with an if statement if I equals j.
Yeah, definitely. So let's do it this way, and then we can talk about Aiden's comment there. I equals 1, and this will get diagonal elements. So we see the 0, 0, the 1, 1, the 2, 2, the 3, 3, 4, 4, 5, 5, 6, 6, 7, 7 down there. And then there's still that one extra guy that we had set earlier. Again, you could do this inside the initialization. You could say something like if I equals j, then yada, yada, yada. I still think it's better to do it with a separate loop, although it's getting close. And at the level of programming that we're doing in this class, it hardly matters. Okay, where this matters is when you're doing high-performance computing with thousands of processors and billions of unknowns. Then you have this extra if statement in there, and everybody's complaining, why is your program running so slow? Because you've got this if statement in there for initialization, and you're doing it 4 billion times, and you don't need to. Questions? Okay. I wanted to finish with a bit of a sketch of how this cellular automata program is going to work. And again, let me remind you what it looks like.
That's starting with that initial rule, right? Like 110.
Yeah, so that's rule 110, and let me in fact break it a little bit earlier. So this thing is printing row by row in a way that's very similar to what I showed you earlier when we were printing out the random digits in the single one-dimensional array. So here, you can't see it here, but here's the first row. How do you imagine what do you imagine about my array there in my program? I'm not going to show it to you, but what do you think that array is? What's its type? How big is it?
How wide is screen?
It's 80 characters.
So it's 85.
So
Just 80.
it's an 80 element array. What data type do you think I'm using? I am actually using int. I could go a little bit smaller. I could use a character array, right? But it's just easier for me to use int. So I used int. I have two possible states for each entry, right? What are they? Dead and alive. How do you think I represent those states? Well, how about in the array itself? Yeah. Zeros and ones. Okay, 0 is dead, 1 is alive. And you can imagine how I print this row out, right? What does that look like in my code? It's a loop. It's a for loop. It loops how many times? 80 times. And it has that if statement in there that we talked about, right? If it's a 1, print out the live character. If it's a 0, print out the dead character. When it gets to the end, it'll probably do an end line. So, what's the first step in the drawing of this cellular automata? Forget about the rule number and all that sort of stuff. We talked about that on Friday. I may talk about it again on Wednesday. What's the first step in drawing this thing? Print out the array.
Yeah. But you have to change your news from the array.
We're just going to print the array using live dead characters. What's the next step? How do I get the next line? How do I get to the next line of my...
Is there like a for loop in your draw statement?
I will give this away. Here's the first row, and this is just me setting the middle character to alive and all the other characters to dead. And this guy is the same array. I just printed it out again. And then I printed it out again, and I printed it out again. So in order for this next row to be generated, I actually have to apply the rules, right? So what I do is I apply the rules and generate the next generation. Which is, for me, a second array, B. Now, this guy prints A. And what I'd like to do is go back there. So what's step 3? Copy B into A. And that's essentially it. That's what's going on in my program. I print out A, which I start out with an initial configuration. I apply the rules to generate the next line, and then I take that next line and I put it back in for A. And I do that over and over and over again in perpetuity until I hit Control-C, Emily.
So like if you were we're applying the rules to say like the ith character, if we write in like I minus 1, does it understand that?
Yeah, I promised to talk about this more, but for those of you that want to start hitting this a little bit, here's a recipe. Remember we talked about that binary stuff last time, where we look at the three guys above and we change that into a binary number? Here are the three guys above. Here's BI. Directly above it is AI. Directly above and to the left is this guy. Directly above and to the right is this guy. Directly above and to the left is the 2 squared slot. Directly above is the 2 to the first slot. Directly above and to the right is the 2 to the 0 slot. I take that number and I turn it into a value between 0 and 7, which corresponds to the entry in the rule array, and that's whether you're live or dead. Something to think about that I will talk about next time is what happens if I is 0 here? There's a problem. This guy falls off the left side, right? And what I asked you to do was use what are called periodic boundary conditions. So in the case where I is equal to 0, this guy turns into the guy at the far right.
Oh, so that's what happened. Yours.
Yep. And where is the other problem? When I is equal to n minus 1, or 80 minus 1, 79 in this case. When I is equal to n minus 1, this is an, which is not legit, right? So what do I use for that guy? If it falls off the right-hand side, wrap it around and use the left-hand side, which is what? A0. So see if you can get that going, and we'll talk more about it on Wednesday.